This is Laura Duncan from CSMS. Today we'll be graphing the equation of the line written in y equals mx plus b form, where m is the slope and b is the y-intercept. However, we start off with a equation of a line that is not in y equals mx plus b form. So how do we get it that way? Well, we're going to isolate the y. To isolate the y, we'll treat this like an equation, and we will subtract whatever is on the side of the y, or do the opposite really. So x is on the side of the y, and we will subtract x from each side. I'm going to rearrange this so that x is first, so that we reach our goal of y equals mx plus b. Now that our equation is in slope-intercept form, we can find the m, it's the coefficient in front of the x. It is an understood 1, or -1 here. Now the y-intercept, where we will start, is the point 0, 3. It's where it hits the y-axis. He's kind of a bully. We'll move over to our graph now. We'll start where the line hits the y-axis, which is 0, 3. And now we'll use our slope to move. Our slope was -1, so it would be -1 over 1 or 1 over -1. So as we use our slope, we're looking at the rise over the run. This would be down 1 and right 1. So put a few points on there. If we wanted to go the other way, we would be going up 1 and left 1. And you can see that no matter what direction you're going, it will still be in line with the other points. Please grab your straight edge and draw your line. Please make sure that your line goes through the entire plane and it has arrows on the end showing that it goes on forever and ever. Let's go on to number 2. As we look at number 2, remember what our goals are. Our goals are to graph the line. And if we're going to graph the line, an easy way to do that is to put the equation of the line into slope-intercept form. That way we can find out our m and our b and then graph it. So to do that, we will do the opposite. We'll try to isolate the y by doing the opposite of each term. So this would cancel out. Remember that if it's a negative y, you need to bring that negative down. I'm going to rearrange this so that the x comes first. Now we'll do the opposite of multiplying by -1. We'll divide by -1. Now when you divide by -1, I want you to remember you're dividing each term by -1. So we'll have y equals 3x plus 6. So now, what's our m? Our m is the coefficient in front of the x, which is 3. It'll be a rise over a run, so you could write it as 3 over 1. And then our y-intercept, our b, I want you to write it as a point, the point 0, 6, where it will hit the y-axis. Now let's go over to our graph and graph it. Now looking at our graph, we're going to first start with our y-intercept where it hits the y-axis. So we'll count up 6. That's the point 0.06. Now we'll use our slope to figure out some more points. The slope was 3 over 1, so that means we can go up 3 and right 1 to find another point on this graph. However, that's the only one I can do going that way. Let's go down 3 and left 1, the opposite. So from that point, we'll go down 3, left 1. You'll be looking at your dots and making sure that they make a positive slope because our slope is positive. Now using your straight edge, please draw a straight line through the points. Now please check over number 2, pause the video, and try number 3 on your own. Remember, on number 3, our goal is to get the equation in slope-intercept form, y equals mx plus b. So we'll subtract 2 from each side, and then we'll do the opposite, but by dividing each term by -3. So we end up with the equation y equals 2/3 x plus 3. Notice that the slope is 2/3 and the y-intercept is the point 0, 3. Now graph that line on your own and pause the video, check in a moment. That's my y-intercept where we begin at the point 0, 3. Now we'll use our slope to go up 2 and right 3. That's our rise over our run. Please check yourself. Does your observable graph match the slope in your equation? Did you put arrows on the end? Let's move on to the next page. Number 4. This is where we panic. We forget our goal. Our goal is to have the equation of the line in slope-intercept form so that we can graph it. To do that, we will do the opposite in order to isolate the y. So y equals 2x. Well, where's the b? There is no b. Well, there is a b, but the b is an understood 0 here. So the slope goes through the origin. This can also be referred to as an equation that has direct variation or proportional. So if it starts at the origin and it's a linear equation, then it is a proportional relationship. Now let's use our slope of 2 to make more points on this graph. We'll go up 2, right 1, and put several points on there, please. You must have at least 3. Now please pause the video and draw your equation of the line. All right, please check yourself. Make sure you've written your arrows at the end and make sure that you have a straight line. Now here's something that'll blow your mind. Go back and try to graph the parent function y equals x. Let's move on to number 5. On number 5, it asks which ordered pairs are solutions to each of the equation. So when we're given an equation, any point that is a solution is a point that is on the line. So to test this, we can test the x and y value by substituting it into the equation. So we'll substitute and then simplify. We have 2 times -7 minus 5 times the y value, which is -3. If this equals 1, then it is a true statement and therefore a solution to the equation. If it's false, it is not a point on the line. So this happens to be true because 1 does equal 1. Since it's true, then -7, -3 is a point on the line. Let's do the next point, 7, 3. So I'm going back to this equation, 2 times our x value, which is 7, minus 5 times our y value, which is 3. If that equals 1, then it's true. So this is 14 minus 15 equals 1. Well, 14 minus 15 is -1. Therefore, it is not a true statement. Since it's false, it is not a solution to the equation. Let's look at point C, 2, 1. I did something that you should never do. I just erased all my work. We want to see your lovely work, so be sure and leave it. So I have 2x minus 5 times the y value, which is 1. If that equals 1, then it's a true statement. However, this is -1. They are not equal, and therefore C is not a solution. Let's try D now. I'm going back to my equation up here. 2 times my x value, which is -2, minus 5 times y, which is -1, equals 1. If that is true, then we have a solution. If it's not true, it's not a solution. When I simplify this side, it's 1. 1 does equal 1, that's true, and so therefore A and D are solutions to this equation. Let's move on to number 6. Let's begin with the point 1, 3. We will substitute it into our equation. So 3 times our x value, which is 1, plus 2 times our y value, which is 3, should equal 11 if it's true. So we have 3 plus 6 equals 11. 3 plus 6 is 9. That does not equal 11. Therefore, A is not a solution. Let's go on to B with an x of 3 and a y of 1. So we're using the same exact equation. It's a little tedious sometimes. So we'll have 3 times 3 plus 2 times our y value, which is 1. Does that equal 11? So we have 9 plus 2 equals 11. Aha, we have a match. If it's a match, then it is a solution. That is a point on that line. Try C and D for yourselves. Please pause the video. Please check over your work. And the lesson is yours.